Hey there, myself Krish Raitrukar, and very warm welcome to all. And this is a day for AI series, and in this we especially talk about little bit cross entropy. Because of that, cross entropy such as an important like it's is an important space of entire artificial intelligence, and because of that is really important. If I say because of that whole concept is really important, but that particular one is really very important for optimization purpose in artificial algorithm. When we actually train the algorithm, we always try to just make the algorithm to in like efficient in such way like they can learn much better about it. So in such way like okay, this particular algorithm is like look toward this, and this is a particular gap, and just you need to fulfill it and just your make your improvement. So algorithm always just try to move toward their higher learning rate. They try to learn much about it. Always they try to learn. This is the main idea behind the scene, and so that's the cross entropy is very helpful for the particular stuff, and this is the important hidden concept, and we should to focus on that particular area first. So okay, so let's talk about cross entropy. I think cross entropy is like similar loss function, uh, like cross entropy loss. We can say cross entropy loss. So because of that, like cross entropy, in cross entropy we actually focus on that a little bit about like how much the loss your actual and predicted output, like two different probability distribution. So previously we discussed like probability distribution in such a way like okay, probability distribution is all about, let's suppose you have a particular event is sure, then how can you say this particular event is sure? What the basic parameters are behind the scene? So how much the each parameters contribute an important role. So cross entropy is all about like something okay, different, like if you want to just distance between two different probability distribution, then you can just move toward their cross entropy. I know it sound abstract, but I try to explain you. Okay, let's suppose your model predicts something, spam. Okay, or not spam, your model have a make the binary decision like spam and not spam. I think you give a particular email and they predicted, yeah, this particular email is spam, but this is not a spam. This particular email is not spam. Okay, what happened? Your particular model, okay, so your model actually predicted spam, but actual output like not spam. The model tried to understand what is the basic probability distribution, and how much the actual and predicted outputs are distant from each other, how much they are, and they move toward the penalty. That's we call the cost. So here we talk about the truth prediction, for truth and prediction distance. We talk about the distance between truth and prediction, how much the truth and prediction are different from each other, how much they have a distance. And we move toward the cost. Cost is all about penalty. Penalty is like something okay, just I will recap you that this particular concept is really important of reinforcement learning. Previous like couple month ago, just we discussed a little bit about reinforcement learning. That's a really interesting concept. Reinforcement learning is like just as magical idea of the artificial intelligence algorithm, where we actually understand how actually model try to learn by giving a just as you're teaching a child, you give a reward as a chocolate. Okay, you do particular stuff, then I give you a chocolate. Okay, and so that's the basic thing. Is like something grid. They do particular stuff with their grid, similar like in machine, but in different way. Machine not want chocolate and something materialistic things, but they actually focus on that what the basic thing is like positive and negative number. So in that particular cross entropy, just calculate and just keep a negative number. In okay, so let's suppose spam and not spam. They calculated the what the distance between their both of them, and they figure it out like what negative penalty we need to just give to the particular system. And after this penalty they want to recover, and they want to learn from this penalty. Okay, so this particular, this how this minus 10, the difference between the minus 10, yeah, so this is particular minus 10, and we need to recover it, and we need to adjust some all the parameters in entire neural network and machine learning, so it can just work on this particular step. So that's the basic thing in that cross entropy, like it is a try to minimize the error. So we move toward the penalty, just to minimizing the cost error. Like always we know about gradient is always moving toward the gradient descent. Especially gradient descent is moving toward the minimizing the loss error, give a specific direction and the parameter, how can we just adjust to just move toward the minimizing the error. So that's the basic thing. I think if you are interested in like mathematical formula, this is the only for you. If you are just interested in like P and Q, let's suppose this two parameter, one is the like little bit true value, and this is predicted value. If you just want to just figure it out, like how much they both are different between both of them, like how much the distance between both of them, and that's really help us to just find out this mathematical operation running behind the scene. Uh, there were two types of cross entropy. First is binary cross entropy, and the second one classificational cross entropy. Uh, okay, so binary cross entropy is like something when you want to just make binary decision like 0 and 1, yes or no. And classification cross entropy is like something when you're talking about like all the entire groups of which particular feature is dominating over the entire landscape. So you look toward the specific features how it's work. So the basic classification entropy work here. Okay, that's really interesting one. And really, let's suppose I try to explain you with a graph. Okay, this is the predicted value p and this is true value. If you want to just figure it out the distance between both of them, and you apply the penalty, what kind of penalty we need to just give to the particular model to for this particular stuff they do. Okay, so let's suppose you keep your child alone in your home, and just you move toward the market. Okay, and when you come, just okay, your child do some break down some kinds of the glasses. You give a punishment, okay, in such way like, okay, I give a punishment in, okay, to particular I cannot recover this particular stuff, but we give a punishment. So that punishment really helps us to memorize when they actually when you actually not in your home, so that they understand, they memorize that particular stuff. We get a particular punishment for doing that particular stuff, they can't do particular stuff. So like similar in the cost, cost is all about minimizing the error by paying a penalty of the particular model. So if the distance between both of them like p and q here, like p and q, that if you just want to just distance between both of them like p and q, how much they far away from this, and we calculate this the cost of each, like how much the cost we need to just pay for this particular stuff. So that's all about cross entropy. Cross entropy is very important rule, is like only for at the end of the algorithm, like model predicts something, and we need just to figure it out like how much the distance between both of them, and then after we just move toward that paying penalty and improving the model accuracy much about it. Okay, that's enough for today. And again, if this one is going to productive for you, if you learn something from there, then it's my pleasure. See you soon.